This is the Archimedes principle experiment. Just as the extra credit was stipulated, I'm gonna test Archimedes principle on 3 types of ice. First, I'm gonna use regular ice. Then I'm gonna use ice with a nail inside. Then I'm gonna use ice with a bubble of air inside. So for my bubble of air, it was like a little hard to have. So what I did is I used a plastic ball of a known diameter, but a very negligible weight that I put inside, and then I froze the ice outside. So the ball is taking the space of the air, if you would say. And I'm going to use measuring cups, and just for consistency, I'm gonna fill all my cup up to 250 millimeters when I put the ice. So I'm gonna start. So this is the regular ice. Okay, my ice was melting, so I guess it doesn't matter. And this is 250 millimeters. Okay, yeah, so it reached 250 millimeters. Now I'm gonna measure the rest of the water displaced, which is theoretically the volume displaced by the ice. So it's 73.2. Okay, so now I'm gonna fill it for the second ice. So our ice is done melting. I don't know if you can see clearly, but for the first cup, it's basically this one, where we put the regular ice. As predicted, the level of the water will not change. So as you can see, it's still at the 250 millimeter mark. And for the second one, it's almost at the 250 millimeter mark. This is the one with the nail inside. So when I remove the nail, it's probably gonna drop just as predicted, because the volume of the melted water is going to be less than the volume displaced by the ice and the nail. So I'm going to go ahead and remove the nail and just observe again my results. Okay, so I'm removing the nail. So as you can observe, if I zoom out, the water now has become a little below the 250 millimeter mark. So now I'm going to measure to compare with my theoretical values. So the first one, the regular ice, I'm going to measure the final volume. So as you can see, the final volume is right at, let me move it away. Oops, better. So the final volume is right at 250 millimeters. And that's just where we want it to be. Notice that I'm subjecting myself to error because first, not using very precise instrumentation, but also reusing the same cups over and over. Some droplets of water are staying, so it's influencing my result. So now I'm going to measure the final volume for the ice with the nail. So yeah, so as we can clearly see from here, if you take a look, if I put it this, maybe I can zoom out. Oops, it's not focusing. Okay, I hope you guys can see it, but it's right at 200 and, okay, let me, so it's right at the 240 millimeters mark. So that's the final volume for the ice and the nail. So as for the ice with the pocket of air, as you can see, after it melts, it's still at the same level. I don't know if you can see, but it's still around the 250 millimeters mark. Theoretically, it should be a little less, but when you think about it, the amount of volume that air occupies, or the mass of the air, is very minimal compared to the ice, and that's why it's right around the 250 millimeters mark. And I'm going to go ahead and measure the final volume. Okay, so for some reason the final volume is 260 millimeters. So my first two experiments went very well. The one with the regular ice and then the ice with the nail. But as of the last one, for some reason, I kept getting more water than I should at the end. I tried it 2 more times, but it kept giving me the same thing. And I was thinking about the possible errors. And I thought maybe the ball is not a great idea to create a pocket of air, first of all. Because real air, once the ice is melting, is not going to occupy space per se, any space in the water, because it's just going to dissipate or evaporate. So I think, using the ball to create a pocket of air was not such a good idea to do this part. And that's the reason. But other than that, I got decent errors on all of my trials. So I'm happy with the experiment.